In this video, we're tackling imaginary numbers on the ACT. As a math teacher who's worked with this topic for years, I'm going to walk you step by step through the exact process to solve these problems so you can save time and boost your score. And if you stick around, I'll even share a calculator trick that makes it feel like a cheat code. I hear from my students all the time that imaginary numbers are one of the toughest topics in math. My goal is to break them down piece by piece, concept by concept, so that you can confidently approach every problem and improve your score. So let's get into it. In this first problem, we have which of the following numbers is an imaginary number? Each one of these we have to look at and determine what imaginary is. So imaginary, if you think of everything you know and have learned until imaginary as a real number. That is a real number. You might have rational numbers, you might have irrational numbers, you might have integers, and these are within themselves. But even more than that, you have what are called complex numbers, and within the complex space is your purely imaginary numbers. And so purely imaginary are things that have an I. Complex are something like a plus bi, which we have referenced before in an older video about the basics of complex numbers. But we just have to figure out or simplify what all these are. The square root of 64 is just 8. We know that that's a real number and it's not imaginary. The square root of 11 is irrational and it can't be simplified any further. Here in this bottom one, we can multiply by the conjugate of the square root of 3 on the top and the bottom to get rid of our square root on the bottom to get this to be 3 on bottom, and then negative 4 square root of 3 on top. And that's just a funky irrational number because there's an irrational number on top. Over here, we have a negative square root of 64 in the square root. What is that negative under square root going to do? Well, that's going to turn into an I, along with that 64 being an 8. And then this last one, negative 8. But we've already figured out that D is our right answer because it has the I. And that's how we can do that first problem. Let's look at our next problem here. Given a positive integer n such that I to the n is equal to negative 1, which of the following statements about n must be true that I squared equals negative 1? Now, in our last video, we looked and noticed that the powers of I run through a cycle. And as long as you can figure out what part of the cycle these are on, you can figure out what I to whatever power is. And so we're looking for something that makes I raised to the n power equal to negative 1. Now, that means it must fall under I squared. So if we were to take something like, show you an example, I to the 22nd power, we can split this up into a bunch of I to the fourth, because I to the fourth is just 1. We can split this into I to the fourth times I to the fourth times I to the fourth. Lots of dots. If you're not paying attention, you can get lost. Times I to the fourth times I squared. And that'll give us, if we were to use the power rules of multiplication, you add these all up, that would give us 22. But this is actually 1 times 1 times 1 times 1 times 1 times I squared, which would be negative 1, giving us just negative 1 for our answer. So we have to figure out what do we need to do so that it is the value of n. When we raise that I to the power of n, it's always negative 1. Now, to do this, we have to divide that number by 4. And whatever our remainder is, whether it be 1, 2, 3, or 4, will determine what our actual value of that I raised to a power is. And in this case, we're looking for when it's negative 1. Therefore, we have to have our remainder be 2. When it's divided by 4, the result is a multiple of 2. Let's look at this next problem. When the imaginary number I is defined by I equals the square root of negative 1, right here, this is all stuff you already know. You know that I is equal to the square root of negative 1. It follows that I squared is equal to negative 1. All this is just math fluff. It's good to know these things and have it here, but it just makes the question longer and makes it more confusing. Based on this information that you already know, which of the following is equivalent to I cubed plus 4i, that quantity over the square root of negative 9? All we have to do here is simplify. Well, how do we simplify, at least in this denominator? Well, the square root of negative 9, that's negative is going to be an I, and the square root of 9 is 3, so I know 3 i's on bottom. On the top, I can take a GCF of I out, leaving me with I, not x, I squared plus 4. I can cancel out the i's on top and on bottom, and that's left me with I squared plus 4 over 3. Ooh, well now what do I do with that I squared? Oh, remember I squared is negative 1. And you should just know that if you're going into the ACT. And if you don't, check out some of my videos. That'll leave me with negative 1 plus 4 over 3. Negative 1 plus 4 is 3 over 3. That is 1. Leaves me with B as my answer. Let's move on to this next one. Which of the following is the correct simplification of the expression 2 plus 7i minus 4 minus 3i? Honestly, this should be a very simple question. You just treat these i's as if they were x's, and the only difference is you write them as an I. So we can distribute that negative, making this a negative 4 and a plus 3. So 2 plus 7i minus 4 plus 3i. We can combine our 2 and our negative 4 being negative 2. And then our 7i and our 3i to be plus 10i, making our answer C. Given that I is equal to the square root of negative 1, which of the following is equal to 11 plus 4i, that quantity, times the quantity of 2 plus 5i? So we have to just FOIL here. It's just foiling. We just have i's instead of x's. So when we FOIL, we multiply first. That's 11 times 2, which is 22. And then we multiply our outer terms. Oops, that was a really bad arrow. 11 times 5i, which will be plus 55i. And then we have 4i times 2, which is plus 8i. And then 4i times 5i, which will give me plus 20i squared. Now remember what is I squared? I squared is negative 1. So when I take negative 1 and multiply it by 20, I'll get negative 20 instead. So I'll have my remaining parts of this expression that I'll write in here. And when I'm add together 20 and 22, and negative 20, that'll leave me with just 2, and then 55i plus 8i should give me plus 63i. So 2 plus 63i is my correct answer. If you understand that imaginary numbers, or specifically not imaginary, complex numbers, things of the form a plus bi, the only way to get it to be something that isn't in this form, a plus bi, if you multiply it by another complex number, is if it's in the form of a minus bi. So unless it's like 11 plus 4i and then 11 minus 4i, we know that it's going to be a complex number, and we could immediately have gotten rid of both a and b. And if you didn't know the rest of it, you could have a 1 in 3 shot at guessing. So, food for thought there. On to our next question. If I squared equals negative 1, which of the following is a square root of 8 minus 6i? Now, this is a pretty tough question. You're just going to have to basically multiply each one of these answers to itself. If it's me, if I'm doing this problem, I'm just going straight down the list because I don't have one way or another a secret weapon of this is the tactic to get. This is just, you got to get the work, you got to be quick, and you got to be smart. So if we multiply 3 plus I times 3 plus I, we FOIL, we'll get 9 plus 3i, with our inner terms another 3i, and then our last terms plus I squared. So when I add these together, this I squared is negative 1. That should be 8 plus 6i. Now it's not 8 minus 6i, but it's pretty close. So honestly, that might be a really good guess as to whether or not this is correct. But we got to check just in case. If we multiply it by 3 minus I, so when we do our first terms, that's 9. Our outer terms, that's a minus 3i. Then we multiply our inner terms, negative I times 3, that'll be negative 3I, and then negative I times negative I will give me a plus I squared, giving me this negative 1 once again for the I squared, which will be 8 minus 6I. And we got lucky that it was the second one. So, you're just determining what's the square root. It's just simple. Can you just FOIL these things out and try to make it a little nicer? Moving on, given that I is equal to the square root of negative 1, which of the following is equal to this whole mess, the numerator being I, the quantity of I plus I squared plus I cubed, all over the quantity of I cubed plus I to the fourth plus I to the fifth. I personally love this question because it looks extremely hard, but actually it's extremely easy if you know what the first step is. And the first step, I hope you know what it is finding the greatest common factor. Now, to find the greatest common factor of the numerator, all of these three terms have an I. So if I take a GCF out, I'll be left with 1 plus I squared. All over, if I take a GCF out of the bottom, a GCF of I cubed, I'll be left with 1 plus I squared. Now, there's several ways you can go about this, but what I would do, and the easiest thing I would say to do, is you have the same trinomial on top and on bottom, and you can cancel those out, leaving me with just I over I cubed. You can go about this multiple ways. You can convert this I to the third to negative I, and that can be just basically negative 1 because anything over itself is 1, but this is just a negative on bottom, so it's negative 1. You could take the quotient rule and have 1 over I squared. I squared is negative 1. And then your answer is negative 1. So I know that several ways that negative 1 is my correct answer. Moving on, which of the following, and this is actually a really cool problem. It's graphing on the complex plane. Sounds really tough, but it's not. Which of the following points represents the complex number z equals negative 3 plus 4i on the complex plane? Now, you can't see it that well, but your imaginary numbers are on your y-axis, and your real numbers are on your x-axis. Now, for a complex number, it's in the form of a plus bi, where a is your real part, and b, obviously with the I right next to it, is your imaginary part. So all of your points are just going to be the form a, b, just like in the xy coordinate. You know, the xy coordinate, it's just your a is your first one, your b is your second. So in this problem, negative 3 plus 4i, what is my value of a? Well, it's negative 3, and my value of b is 4. And so I can graph that. I mean, I already have the answer, but I'm going to graph it anyway. Negative 3 and 4. Boom. There's my answer right there. So b, negative 3 and 4. Now let's take a look at how to use this with a calculator. I'll be honest, this is the only way I know how to use this with a calculator. But if all we have to do is just plug all this stuff in. And how do we do that? Well, we just do 2 plus 7, and then we do I, which is second, and then the decimal, and that's all there is to it. Minus 4 minus 3 I, close parentheses, and what do you know? Negative 2 plus 10i. We can even look at this FOIL question we did earlier, which says 11 plus 4i. And you can definitely type this in faster with your own fingers. 2 plus 5i, what's that going to give me? 2 plus 63i, which is my correct answer. Thank you for listening.